Hello students, welcome back into the another session on software testing. Students, in the last lecture we discussed about the white box testing. We started our discussion with the understanding the review process, that is the static testing, and then we moved on to the white box testing. So white box testing is a testing technique wherein the tester will have the knowledge of the entire software structure. And by having the knowledge of that software structure, test cases will be designed. So white box testing can be performed using these three techniques. One of these is a control flow testing, second one is data flow testing, and third one is coverage testing. In the control flow testing, our concentration is majorly on the control of the software. So how the software is changing the flow through the control structure, like if and else, switch, loops, that will be concentrated in the control flow testing. Then next one, we have a data flow testing, wherein our concentration is how the data is flowing through the software. So where the data is being accessed, how the data is being initialized, then modified, again then will be accessed, that will be tested in the data flow testing. And then afterwards we have a coverage testing. So in the case of coverage testing, our major focus is on the number of lines of code which we have tested. So for example, if we have 100 lines of code in the coverage testing, we have to execute at least 80% of that code, means 80 lines of code should be tested. So we have to design our test cases in such a way so that 80 lines will be executed, they will be tested. So that's what is the part of a coverage testing. Now we will see control flow testing in detail. But before that, we will see what is white box testing and what are the advantages and disadvantages of white box testing. This is how the testing process will go on. So initially, software under testing, that is SUT's implementation, will be analyzed. So the entire code which is written inside in the software, that will be analyzed. From that, we will identify different paths which are available in the software. Then we will choose the inputs so that each and every path which is available under the software will be executed. So that is called as a path sensitization. Path sensitization is a technique, or it's a way to do the testing in which each and every path will be triggered at least once. So we will make sure that each and every path which is written in the software will be executed at least once, and this is how we will choose our inputs. Then from the inputs we will calculate the expected outputs. So as we know the entire logic of the software, as we know the internal structure, we can determine what will be the probable output of the corresponding input sets. So that will be determined, and then actually outputs will be compared with the expected outcomes. So if actual output is matching with the expected output, then that test will be marked as a pass test. So that test was successful. And if actual output is differing from the expected output, then that test will be marked as a failed test case. So this is how this entire testing will be carried out. The applicability of the white box testing is throughout the system development, meaning that this particular white box testing can be applied at all levels of the development, right from your unit testing to then integration testing to then the system testing. We can expand our horizons towards all these segments of the software. Basically, it is called as a part testing. The reason because in the white box testing we have the access to the internal parts of the software. So this particular testing, that is the white box testing, can be applicable throughout the life cycle of the software, that is from the small module or a small unit of the software towards the integration of the software towards the entire system of the software. So from unit testing to the integration testing, and from integration testing to the system level testing, at all levels this particular testing can be carried out. Now there are some advantages and disadvantages of having this testing technique. The advantage is, of course, every path within the software will get identified and that will be executed at least once. So this is the advantage of having this particular testing technique first implemented. There are some downsides or disadvantages of having this testing technique. The first one is the number of execution paths may be so large. If your software is big, there are possibly number of paths will be existing in your software. If you take all the permutations and combinations of all the paths, then that will be really huge. So if you want to exercise each and every path of that software, then sometimes it is not practical. So that's why the number of execution paths, if they are too much in the system, then that can be a downside of this path testing. Then the test cases chosen may not detect the data sensitivity errors. As of now, we are only concentrating on the different paths which are existing in our software. So our concentration is not there on the data. So probably the data related errors cannot be catched in this testing. Let's say suppose, as I discussed last time with the example, that if you have certain number and you are dividing that number by 0, okay, so that sort of error will be only exercised when you are concentrating on the data. But when you are concentrating on the paths, probably that particular error cannot be discovered. Hence, the data sensitivity related errors cannot be figured out, cannot be found out using this approach. Then the third disadvantage is that while we are performing white box testing, generally it is assumed that the control flow of the software is correct. The reason over here is that we have already exercised or we have seen the paths which are existing in the software, but there are many times non-existent paths can also be there in the software, which will be triggered only after certain condition will be met. So because of that, while we are working with the white box testing and while we are exercising all this path testing, at that time we generally go with the whatever the paths that we know, and those paths are probably the correct paths, or the flow over there for the control is the correct one. But if you go with the unexplored paths where the paths are not determined or these paths cannot be executed many times, then those errors or those control flow errors cannot be figured out in the white box testing. So that's where the white box testing has a shortcoming. And another disadvantage, or rather this is a compulsory thing, that the tester must have the programming skills. So here the tester should have the testing skills along with the programming skills. So whichever the programming language which has been used for the implementation, so the tester must have the knowledge of that programming language. Otherwise, tester cannot perform white box testing. So these are some of the shortcomings or disadvantages of the white box testing. So in the control flow testing, it identifies the execution paths through a module of a program code. So generally we concentrate on the path and the basis path testing. It creates and executes test cases on the paths and the basis path testing. Now the difference between the path and the basis path testing that we need to understand. Path is anywhere from source to the destination. Whatever the connected nodes are there that you have to cover. Let's consider I wanted to travel from Nasik to Pune. So now there are number of routes which are available for me. The one of the routes which is available to me is like I will start my journey from Nasik and I will take Sangamner and I will go through the city of Sangamner and then I will reach to Pune. Another path which can be existing, like I can start from Nasik and probably I wanted to go to Mumbai, and from Mumbai I will reach to Pune. There can be other path that I will start from the Nasik and then I will take the route via Sangamner, but not through the Sangamner. I will go and bypass the Sangamner and then I will reach to Pune. So this can be the another path. So when we are concentrating only on the path, our concentration is like from how we are starting the journey from Nasik and whether we are reaching to Pune or not in a proper way. But in the case of basis path testing, our major focus will be on the possible paths which are available, and we will try to reach Pune through whichever the or possible paths are available to us. So whichever possible paths are available, we will try to explore all these paths to reach to Pune. So that is what we generally focus in the basis path testing. So we will explore this in more detail. Now here are two examples to understand control flow testing in different ways. So let's consider I have a only path available over here, that is the sequential path. So right away I will start from the source and I will reach to destination, and as there are no any other paths existing, I will need to only exercise this path, and there is only one node I will need to exercise. So here this particular control flow testing with respect to this particular diagram is very easy. Now let's consider we have a conditional statement over here that this C is evaluating to be true or false. So if C is true, then S1, this node will be executed, and then we are arriving on this node, that is the last node. And if C is false, then we are taking the other route, that we are coming through the S2 and then we are reaching to this particular node. Now in any way we are reaching to this node, so the source and the destination nodes are same. But as this is nothing but a path testing will tell us that C and this path, this source node and the destination nodes are the same. But in the basis path testing we will understand that there are two possible paths which are existing, and we will need to exercise each one of them. So at the first instance we have to make this C as a true, so that it will come through the S1. Probably at the S1 there might be some variables which will be initiated or initialized, or they will be accessed or modified, and then we will come over here. If we take the other route like an S2, here there may be a chance that the different variables will be initialized or modified or accessed. So this makes a sense to check S1 node also with respect to coming to this node, and S2 node also with respect to coming to this node also. So that's why in the control flow testing we have to exercise all possible basis paths. So that's the important phenomenon over here. Here are different looping structures or iterative structures. With the help of them we will try to understand control flow testing. So let's consider this while loop. So as we know, the working of while loop, the condition is evaluated first, and as long as this condition is true, we have to keep on executing this particular block of statements. So if the condition is true at the C, we will come to the S part, and again we will go to the C. Again if the condition is true, again we will come over here, again we will go back to C. The moment this condition becomes false, we have to exercise this another path, and then we have to take this route to reach to this node. So this is how while loop will work. Let's take an example of a for loop. In the for loop, we have certain restrictions that we have to start from particular instance, that is I is equals to 1 to certain value, and that many times we have to repeat this process. So here the way of looking at this control structure will differ. So here we are starting with the I is equals to 1, then we are coming to this S part. This is nothing but the source where we are starting with. If the condition is true, means if I is less than n, we will keep on evolving around this particular loop. Every time the value of I will be incremented. The moment this condition becomes false, we will come out of the loop, and then another route or another set of segments will be executed. So this is nothing but the control flow testing with respect to for loop. Similarly, we can exercise with the do while loop also. In the case of do while loop, there is no entry criteria, so there is no testing at the time of entry. So straight away we will take the entry inside, and the moment we will come to this particular part, we will evaluate the condition. If the evaluating condition is to be true, we will come back to the S1, and this particular process will keep on repeating as long as this condition of C is true. The moment this condition has become false, we will come outside of it. So this is nothing but a way or approach that we have to take while we are working with the control flow testing. Now just remember, in any of the software you will not have the lone part of this particular thing, but you will have the combinations of this. So sometimes you will have independent paths, sometimes you will have the loops, sometimes you will have the if else conditions. So based upon that, you have to exercise different paths which are available, and these paths needs to be considered with respect to their controls. So how this control is working out on those paths, that you have to find out. Now the next concept that we have to understand is a cyclomatic complexity. Now cyclomatic complexity is the number which will define the how many number of independent paths are existing in the program. So we have the formula to calculate the cyclomatic complexity. Based upon that, we can find out how many independent paths are existing in the software. So how we can calculate it? So cyclomatic complexity V of G, V is nothing but the cyclomatic complexity for the graph G is equals to number of edges that we have in the graph minus number of nodes that we have in the graph plus 2. That is what this is how we can calculate the cyclomatic complexity for that particular graph. Other way of doing it is that V of G is equals to P plus 1, and here P is nothing but a predicate node plus 1. Now you might wonder that why we have done with this plus 2 addition, why plus 2, why not 3, 4 or something else. The reason over here is that plus 2 is nothing but here we are finding out the node from where the two different paths will be taken. As we know, in the if else condition there are two paths which will be taken. Either if the option is true, then the path A will be taken. If the option is false, then the path B will be taken. So that's why in order to calculate how many independent paths we have, we do with this addition of 2. So E minus n plus 2 will give us the exact number of independent paths existing in the particular program. Otherwise we have the other formula that we can use, that the number of predicate nodes plus 1. So how many predicate nodes we have? Predicate nodes are nothing but the nodes which will take the decision to take either path A or path B. So based upon that we will decide means a number of predicate nodes plus 1, that will give us the number of independent paths existing in the software. Now with the help of this example, we will try to understand how we can calculate cyclomatic complexity. So here we have a graph, and graph is of course the collection of edges and nodes. So we have nodes over here. So 1, 2, 3, 4, 5, 6, 7. We have 7 nodes over here, and then we have the edges. We have total 9 edges over here. So 1, 2, 3, 4, 5, 6, 7, 8, and then this one is 9. So total we have the 9 edges over here. Now how we can calculate the cyclomatic complexity over here? So the first formula that we know over here is that V of G is equals to number of edges minus number of nodes plus 2. So just calculate how many edges we have. So we have total 9 edges. We have total 7 nodes over here. So 9 minus 7 plus 2, that is equals to 4. This 4 is nothing but the number of independent paths that we have here in this particular graph. Now we will try to explore which are these 4 different paths. So we will start with the node 1, we will come to node 2, then we come to node 3, then we will take this route node 4, then 5, 6, then again we will loop through this, and then we will come to this 7. So this is the path 1 we have over here. Let's take another path. We will start with the node 1. We will come to the node 2, we will come to the node 4, then we will come to the node 5, then we will come to the node 6, then we will come to this loop, and then we will reach to 7. So this is the second path we have. The third path, we will start with the node 1, then we will come to the node 2, then we will come to the node 3, then we will come over here, then we will come to node 4, and from here we will take this particular path, and then we will reach to 7. So this is the third independent path we have. Then we will start from here 1, we will come to the 2, we will come to 4th node, and then we will take this route, and then we will come to this node number 7. So this is the 4th independent path we have. So this is how we have to calculate cyclomatic complexity. Now here in this case we have figured out there are 4 different independent paths are existing, and we will execute all these 4 paths in order to have the better coverage for the code. Now we will see how another formula is also applicable over here. So the another formula says that you have to find out how many predicate nodes are there, and to that predicate nodes you have to add 1 to find out independent paths. Now predicate nodes are the nodes which are determining the different routes. So they are responsible to change the route of your code. So here the first predicate node we can have over here is this node number 2, because this node number 2 we can go to node number 3 or we can go to node number 4. So this is the first predicate node we have encountered with. Similarly, this is the second predicate node we have. From here we can take this route and we can reach to 7, or we have to take this route 5 and 6 and then we can reach to 7. So this is the second predicate node we have. The third predicate node that we have over here is this node number 6, because this node number 6 also is responsible to change the route. From 6 I can straight away go to 7, or the 6 can take me to node number 5 back, and then again I will need to come to 6. So this 6 is also a predicate node. So the number of predicate nodes I have over here is 3 plus 1, and that will give me the number of independent paths that I have in this particular graph. So this is how we can calculate the cyclomatic complexity for any graph. Hope you have understood the white box testing. Under the white box testing, we have just seen the part testing or the basis part testing, in which we have seen the cyclomatic complexity that will give us the exact number of independent paths that we have in our program. Having said that, we will conclude today's session over here. I'll meet you again in another session. Till then, keep studying. Thank you.